Hello, everyone, and thank you so much for tuning into another episode of UCTV Alive for Kids. I'm Dr. Louise Grimmer. I work in the business school at the University of Tasmania, and this week I'm really excited to welcome our special guest, and his name is Mark Shelton, and he's from University College at the University of Tasmania. Welcome to the show, Mark.
Thanks for having me, Louise. It's great to be here. Really exciting.
I'm very excited about your presentation today. You're going to be talking to us about using technology to bring imagination to life. And specifically, we're going to look at 3D printing, which is really a new topic for me, and I guess I'm assuming for some of our audience as well. Before we get underway with your presentation, can you tell us a little bit about yourself and what you do at University College?
Absolutely. So I'm a lecturer in the Associate Degree of Equipment Design and Technology. We're based in Burnie, so we have a facility in South Burnie where we do lots of amazing things, and you'll see some of those examples today. University College is, I suppose, an arm of the university that focuses on experiential learning, or project-based learning. So our students work really closely with industry to come up with really cool projects and to solve a lot of problems.
Well, I think we should get underway with your presentation. And while Mark is presenting, you could be thinking about some of the questions that you want to ask Mark. We'll have the break as we usually do after about 20 or 25 minutes of presenting. So think about your questions, and remember when you're posting them on the chat facility, if you can put which school you're from and your name, that would be fantastic. So Mark, I'm going to hand over to you to give your presentation.
Thanks, Louise. So I've got a few slides that we can go through now. As I said, we're talking about using technology to bring imagination to life. There's been a lot of changes over the last generation, I suppose, in technology and what it gives us the capacity to do. And those things are only rapidly expanding day by day. So we're very fortunate in the course that we deliver to enable our students to develop the skills that will enable them to be the inventors and the creators of the future. So our equipment design and technology course is all about them designing and making really cool stuff. They're kind of like crazy inventors, Louise, is pretty much how it works.
It sounds like too much fun.
It is too much fun, to be honest. Most days we do have a lot of fun. So I'm going to give a heap of examples of that today and talk a bit about, just where things might be headed, especially in relation to 3D printing. Just trying to get the slides to work, which is always a great way to start, Louise, talking about technology, not getting a PowerPoint slide to work, isn't it?
It is good. It is good to talk about technology and then have a technological problem.
That's right.
Just talk amongst yourselves for a moment.
So 3D printers, essentially how a 3D printer works, you take a digital file and you create an object using a digital file. There's lots of different software that you can use to design your pieces of equipment. And then the 3D printer is a fantastic machine. There we go. So there we go. Excellent. We've got our technical glitch sorted out. So 3D printing is a process of making three-dimensional solid objects from a digital file. And the object's created by laying down successive layers of material one on top of the other. So what I've got here is what's called 3D printer filament. So this filament, I'll see if I can hold it. That's okay. We'll hold it up to the camera there. So the 3D printing filament goes into the 3D printing machine, and we'll see a video of that in a second. And it gets really hot, and then layer upon layer, it creates your design. So that's pretty much how 3D printers work. So here's a really quick example, and just while this is playing, so this is a bit of a time lapse. So this is in ultra super fast mode, Louise. But you'll see that the 3D printer, the head there going from one place to another, laying down really fast, different layers of material to create an object. So the challenge here for you, Louise, is to figure out exactly what's being made.
Well,
there.
I did see it flash up just at the beginning, but I'm not going to say anything just yet. Okay. Or do you want me to say what I think it is?
Go on, have a guess.
Is it a green version, a very bright green version of the Eiffel Tower?
I think that's exactly what it is.
And so you've obviously had to do a lot of work inputting information into a computer to get it to do all of those movements.
That's right. So we'll look at some of the software that you use a bit later on in the presentation, but you do have to create your design first and foremost, and then that design is sent by the computer to the 3D printer to tell it layer by layer. So that process is actually called slicing. So what it does, it takes your three-dimensional design and then uses software to slice that. So it knows in each and every layer what it has to do in order to create and build up, as you'll see the buildings start to come together now, your 3D object. So it goes one on top of the other, kind of like if you were building a house using Lego bricks and you went around the side and you slowly build up higher and higher as you
So it's
went.
just layer upon layer upon layer.
That's right.
And Mark, how long would that have taken if we weren't showing it so quickly?
My guess for that one would be somewhere in the vicinity of about 8 hours, I reckon.
So quite a long time. So we've really sped that up.
We have sped that up quite significantly, yeah. So 3D printing does take a long time. That's one of the challenges with 3D printing, but it does enable you to make, you know, extraordinary shapes that you couldn't make with any other fabrication technique.
It's very intricate, isn't it? Because the design of the Eiffel Tower, of course, is quite complicated.
That's
and
right.
to be able to print that is really quite amazing. It's not like you're just printing sort of a fairly basic solid object, which you can do.
That's right.
That's actually very detailed and amazing.
Exactly. So 3D printing fits into the additive manufacturing family of manufacturing techniques. So additive manufacturing means you add material to create an object. Most traditional manufacturing is actually subtractive manufacturing. So you're carving and taking away. So if you had a set of tools and you were trying to carve that out of a piece of wood, for instance, that would take an extraordinary amount of skill and a heck of a lot longer than the amount of time it would take.
And
you'd
be taking things out of the wood to
That's
create
right.
that instead of making it,
Correct.
adding it in.
That's right, yeah. So that's the main difference. So it's additive manufacturing. You'll sometimes hear 3D printing referred to as well. So it's got a lot of capacity to change the world. I think that the main thing that 3D printing gives us the capacity to do is it enables everyone to be able to produce their own goods. So it used to be that in the old days with manufacturing, these are the sorts of people that used to do. We use toys as an example, Louise. So I just typed in toy inventor into the internet, and these were the sort of guys that came up. And they probably had amazing jobs, probably very lucky. So there's very few people that would do the design of the toys, and they would have, you know, the most amazing job in the world, testing different toys. Connect 4, absolutely. And some other sort of popular toys there. And that's how it used to be done. One person would do the design, and then we would create big, long processing lines where we made hundreds, thousands, millions of the toys. So that's kind of good if everyone liked exactly the same thing. If everyone liked the design that the inventors came up with, then that was a wonderful thing. But I think that the awesome part of 3D printing now is that we don't have to rely on other people to come up with our designs for us. We can create our own designs, and we can 3D print them either at school or in the home. And as 3D printers become cheaper and cheaper and more accessible, they'll start to appear in homes all over the world. So rather than just be consumers of products where we go and buy a lot of different things that are made in these processing lines, we'll be able to be inventors and creators. Everyone will have the opportunity to make their own items.
We might see, on that previous slide, we might see some women inventors.
Absolutely.
Some girls and women inventors, that would be, because anyone can do it, right?
And more importantly, I think, Louise, if we're talking about toys, maybe some kids would be cool.
Exactly.
Too, wouldn't it? So
That's right.
I think it does. It gives capacity to anyone anywhere in the world to be creative and to come up with their products. There are some other challenges that this old type of manufacturing used to present as well. So mass production, where we used to make the same thing, hundreds and thousands and millions of them, caused lots of pollution, which is a challenge. And pollution through a lot of the transport. So you'll see the icons down the bottom there. If you think about it, if we have to make all of those products on the other side of the world, we've got to ship them to wherever we're purchasing them. So here in Australia, it causes a lot of pollution, just the transport in the fuel and the resources required to move those products. The other problem with mass production is a lot of the jobs that were involved in mass production are now being carried out by automation and by robots. So in the future, those jobs might not necessarily exist as well. So there's been a really big shift in manufacturing, and 3D printing is playing a really big part in that shift. So it sounds like there's lots of negatives to that, but what 3D printing means that we can do is that we can make stuff at home. So we don't have to worry about the transportation and the pollution that will cause. It will mean that we don't have to worry about robots taking our jobs, because if no one's doing those mass production jobs, that's not such a big issue, and we can only create the products that we need. Because I'm sure you can imagine if you created 1 million of a toy, and a lot of those toys didn't sell, that's a lot of toys that end up in landfill. Whereas this way with 3D printers, we're only creating what we need.
And sort of what we call bespoke things, so things that you've designed because you want to play with that particular toy.
Absolutely.
So it's something that you've created, so it's one special thing often, isn't it?
That's right. So or as we move beyond toys and start to think about what other sort of products 3D printers can make, it's products that can solve really bespoke, as you mentioned, solutions to problems. So if people have got little problems, and we'll show you some projects in a minute, we can come up with solutions that perfectly fit that problem, and we can design those ourselves, which is fantastic, and not be reliant upon what we might be able to find on the shelves in a store or online as well. So the only limit now is your imagination. It used to be that you had to, go and study and hope that you would get one of those toy inventor jobs. But now you can start to do the designs your own, and you can start to 3D print things in your own house. To give you another example of how that's changing the world, Louise, I think something that a lot of the viewers might be familiar with is the way that that TV has changed over the years. So I actually very frighteningly did a bit of a Google search of what was on TV when I was in grade 5 the other day, which is a little while ago. And the first thing that really quickly came back to mind was there was only 3 channels when I was a kid. 3 channels to watch. No internet to search things like YouTube. And those channels only had kids programming in certain times of the day. So you could watch cartoons for about an hour and a half in the morning, and then about an hour and a half in the afternoon, and then on Saturday mornings, and that was it.
Yep, that was it.
That was it. And if you didn't like some of those cartoons and you had to fight with your 3 sisters about which ones you wanted to watch, that was a real challenge. Of course, now, and if we think about how 3D printing might change where everyone can be a creator of products, the way that TV is changing, a lot of kids now, that they can make their own stuff, put it on YouTube, and to watch what other kids are making, which is a fantastic thing. I'm not suggesting we should be sitting there watching TV all day, Louise, but it does give us the opportunity to use our imaginations and our creativity to create content that's really relevant to us, things that we're excited about as kids, or even as we move into adulthood, the things that we're excited about we can create and we can watch. We're not relying upon other people choosing what we do and what we buy and what we make as well, which is really cool, a really amazing shift. So some examples of that, these are some of the projects that our students have worked on in the OEM, and Tessa's going to bring over some of these products for me. The first one is quite big. There we go.
Oh, look at that.
So this is a surfboard created for surfing on wake behind ski boats. So somewhere between a wakeboard and a skimboard, which is, as you can see, so this is a really big thing. It's the first thing you notice. And you'll see the honeycomb shape, the hexagon in the middle there.
That's just to make everyone feel a bit woozy.
The honeycomb shape in the middle is the part that's been 3D printed. And that's done in sections on our little 3D printer at the facility in the OEM. And then they're all pieced together and fiberglassed over to create one board, which is quite an amazing thing. And then on the back, we've got little 3D printed fins as well.
And what about the black bits on the front? Are they 3D printed
No,
too?
That's actually just rubber that's stuck on.
Oh, that's stuck for your feet. Okay.
Yeah.
Oh, that's amazing.
Absolutely. It's a really awesome example. So if we can just jump back to those slides for a second, I'll show you that in action. So our students, when we do our designs, there's a process that we go through. We use a thing called design thinking. So it's one thing to come up with your design, but you've got to test your designs as well to see if they work. That's another really fun part of the design thinking process. So you'll see in the first little picture there, and now there's a little video. This is Keenan. So this is actually the student that designed the piece of equipment. This is him testing it out. Don't judge him too much on his ability to wake surf.
I'm
More on his 3D printing. It's pretty good. He's doing pretty well. But you'll see in a second he's about to drop his rope and he's going to see if it really tests. So that's pretty amazing to think that from a tiny bit of filament, strands and strands of filament, you can design and 3D print a board that will enable you to do that, which is pretty awesome really when you think about it. The picture in the middle there is another project that our student worked on. The other thing that we really like to do is focus on problem solving. So this was a project that was brought to us by the Tasmania Police, And this is actually a guard for one of their drones. And you'll see on the end here that it broke off from their drone. So they needed to put a guard on the end of their drone. So this is where the propeller would normally be for the drone. So they needed our students to design something that was really quick and easy to put on, because obviously in an emergency situation, the police need to be able to put on these drone guards really quickly and set up their drones to help in rescue operations. And it also needed to be really light and really strong, because the reason that this arm actually broke is that it was down in a mine and they flew it into a wall when they were doing a bit of reconnaissance after a mine collapse. So they wanted something that, if the drone did happen to bump into a wall, that they could fly it out without losing that footage and without losing their drone. So it was a really great project for our students to work on, and you'll see them there in the photo. If we just flip back to the picture there, talking to the police officers and finding out about their requirements, so we could understand better what they needed from the design. So 3D printing enables you to print really specific things to solve really specific problems.
And Mark, just before you go to the next one, just you were telling me something interesting about this drone piece. It's got something added to it.
Absolutely. So to make it strong but to keep it light, this has actually got carbon fibre laid through it, which is an incredibly strong material. So we've got a 3D printer called a Mark Forged X7, which is like an industrial super strength printer. And the Mark Forged enables us to inlay materials like carbon fibre or Kevlar. We could even make a bulletproof vest if we were so inclined.
So it's really, really strong, but it's light.
Extremely light. So this was about a third of the weight of the piece that the police could buy commercially. So they could go online and buy something to suit their drone, but it was about 3 times as heavy. Wow. So the number one thing with drones is you want to keep things as light as possible, so they don't flatten the battery.
Yeah, that's amazing.
Yeah, it was really cool. Another example of that problem solving was the face shields. At the start of COVID, you might have seen some of this on the news. There was lots of people 3D printing face shields around the world. And that was a really great example of the collaborative effort of people with 3D printers at home or at schools or at universities like we did. They all got together and came up with a design that they could send out by email, by computer, so everyone had the same design. And we could easily print face shields to help provide equipment for people in the medical health industry, which was fantastic at really short notice on the northwest.
So someone came up with that design, and it can just be sent to anyone who's doing 3D printing, the same design, and then you all just print from that design.
Absolutely. You can receive an email and have something printing within 2 minutes from anywhere in the world. Yep.
And so, Mark, the bit that you guys printed is the sort of solid bit, and then tell everyone what the shield bit is.
So the shield bit, it was actually hard to get our hands on material really quickly. So this is actually an A3 laminator patch that we laminated together. So we spent a lot of time on the laminator over the couple of weeks, because we started out thinking we might need a couple of dozen. That's just as a bit of a process.
Yes, tell everyone how many you were requested to make.
Yeah, so it started out as an idea. We wanted to give the students a bit of a problem-solving thing to see how quickly we could print the face shields. And then at about the same time that week, COVID really took off in the northwest of Tasmania, where we are at Burnie. And we went to local hospitals and they said, yeah, look, if you guys could sort out a couple of thousand, that'd be fantastic. So we had to change our design pretty quickly, and we got it down from about 3.5 hours per face shield to about 4 minutes.
Wow, that's incredible. And I mean, that's a really great example of 3D printing really helping out in an emergency.
That's right, absolutely.
Fantastic.
So a couple of other projects. These ones are a bit of fun that I thought I might bring in, because I know that fashion's very important here on the show.
Absolutely.
So this is my 3D printed tie, which is wonderful, isn't it?
It's amazing.
Really suits me.
I really do think you should actually wear it.
All right, I will, if I can get this clip to work and hopefully not break it. So again, when my students gave a presentation, I gave them a hard time. I said they had to wear a suit and tie when they gave their presentations. So one of them was kind enough to 3D print me a tie.
Amazing. I'm sure it's going to hit, fashion runways in Paris.
That's right. And this little device here, a bit hard to see, but that's actually my big head on a very small scale. So we have a 3D scanner as well. So you can do the designs, or you can just use 3D scanners to input designs into your computer and then 3D print your own head and sit it on your desk as a friendly reminder of how big your head is all day, which is a wonderful thing.
That's incredible.
And the last big example that I'll give to you.
Yes, this is a great
one that everyone gets excited about. Yeah.
Yep. I'll move these out of the way.
So this is our 3D printed tank. So every part of this, except for the little bolts that you can see there, and the camera that sits in it, is actually 3D printed. So the tank took about 240 hours to print, and it's remote controlled. So I'll just lift the lid off here.
Oh wow, look at all the components.
All the components in there. So all 3D printed.
So anything that's not metal was 3D printed.
That's right, yep. So again, bringing imagination to life.
Yeah.
This was something a student wanted to work on. They love remote control things, and they thought, oh, I would love to make a tank. Couldn't buy one, so they thought, we'll 3D print one. And they came up with a nifty device. This is a 360 degree camera. So we can now drive the tank anywhere and get 360 degree footage of wherever it's driving to.
It's amazing.
Yeah,
and Mark, tell everyone what sort of, like, this has an application in space, for example. What were you saying about, the different sizes of 3D printers and how they can be used in different areas,
absolutely.
Like space?
It's a great example, Louise. I think if you think about being on a spaceship, you can't have a lot of spare parts because there's not many places to store it. But if you've got a 3D printer and you can send those files digitally, and you'll see in the top right-hand corner there's a picture of a little 3D printed part floating around in space. You can print anything that breaks, but only print what you need. So 3D printing is going to be a really important part of any efforts humans have moving into space. Some other really cool examples there. In the top left-hander is a Foodini. So that's a food 3D printer that the university has, which I did test when they had it on display at AgFest.
Okay, silly question from me. What do you feed into the Foodini to make the food?
So you can use basically any food product that can be liquefied. So in that instance, they've got tempered chocolate. So they're making a little chocolate, but you could make pasta or...
so you can make it into a great pattern, and that would be an interesting way to perhaps sell different kinds of food.
That's right, yeah. So if you think about maybe decorations on cakes and things like
Yes, of course.
that. And then you can print out 4 different foods at once, so you can make all sorts of stuff.
Willy Wonka.
Absolutely,
sort of stuff.
Willy Wonka. Yep, but without the need for the Oompa Loompas,
Exactly.
unfortunately.
Oh, that's a bit sad.
Yeah. Some other examples there. That's a 3D printed house.
Wow.
In the bottom left-hand corner, which is pretty crazy. So that's obviously a 3D printer on a massive scale. And a really amazing story, the one in the bottom right-hand corner, that's an inventor in Phillip Island in South Gippsland in Victoria. He used recycled bottle tops to create artificial limbs for people using his 3D printer, which is a really cool example of being able to use recycled material, but also being able to make really bespoke parts perfectly fit one person. And in that instance, a little girl that got a new hand.
Wow, that's really incredible. Cool. So that house on the left-hand side, is that made from the plastic filament? That's
probably made from some form of concrete.
Something a bit stronger.
Something a bit stronger, I hope. But you never know.
Wow, that's amazing.
Yep.
Well, that's fantastic.
Yep.
Well, Mark, I've got so many questions, but I'm hoping that our viewers have got lots of questions too. So I think what we should do is go for our 5-minute break, and you all come up with some questions for Mark. And when you're posting them, don't forget to put which school you're from and your name. And so we'll see you back here in 5 minutes.
Fantastic.
Well, welcome back, everyone, and I can see that you've all been really busy with some fabulous questions. And so I'm going to take control of the mouse on my screen here. And Mark, are you ready for some questions?
Absolutely.
Okay, so the first question that we've got, this is an interesting one. Now, this is from Lillian, and she's from St Joseph's in Queenstown. And Lillian says, if you wanted to get a 3D printer, wouldn't it still pollute the earth because you use transport to get it here? Good question, Lillian.
Excellent question, Lillian. And good to see that you're thinking about the impact that transport has. So, yeah, I think you're right. Certainly, if you want to transport it the first time, that would cause a bit of pollution. But I suppose that would then outweigh, if you use that 3D printer for the next 5 years to 3D print 1,000 things that didn't need transport, then it would probably negate that. The other really cool thing that you can do with 3D printers, once you had one, is that you can potentially 3D print a second, third, fourth 3D printer. So you could have a whole gang of 3D printers in Queenstown that were printed from the first one. So, yep,
You
there
can
would
3D print your own 3D printer.
You absolutely can. Yep,
Amazing.
that's something that can be done. So, thank you, Lillian.
That's a good question, Lillian. Now, we have another question from St Joseph's, Queenstown. They've been busy. This is from Lilia, and she says, does it take a long time to build flowers? Oh, you could 3D print flowers.
Absolutely, yeah. 3D printers are really good at intricate design, so flowers would certainly fall into that category. The answer to the question, I suppose, depends on how big a bunch of flowers you want. So if you wanted a little flower about this size, about the size of my remote, that would probably take about an hour, I would say, maybe an hour and a half. So it depends on how big a bunch you wanted. So if it was for Mother's Day, it'd probably take 10 hours.
You need to prepare.
Yes.
So you've got enough time. Now, another question from St Joseph's in Queenstown. Freya, I hope I'm pronouncing that correctly. Where do you get a 3D printer from? That is a fabulous question.
So, look, there are shops that you can buy 3D printers from. There's specialty stores, electronic shops that you can get them from. But most of the stuff, most of the equipment and the materials that you buy, you get online. So 3D printers range from anywhere from, you can get a really good 3D printer now for about $700, which is a lot of money. But if you think about how much you might be able to do with it, you can get a really good one that'll be able to make, you can print all sorts of really cool stuff. Like this was printed on a $700 printer. And that tank actually was printed on a $700 printer on a Sidewinder. Right up to hundreds of thousands of dollars depending on what you want to print, but mostly online.
So they've probably come down in price quite a lot over the years, because I know $700 sounds like a lot of money, but really for a 3D printer, that's probably a lot cheaper than they were when the technology first was introduced.
Most definitely, and the products that you use to print with have also come down pretty significantly as well. So it's like any technology, it takes time, but things gradually come down and down.
And if someone doesn't ask you about the filament, I'll ask you about the filament.
Yeah.
But let's go to some more questions. We've got a homeschool family in South Hobart, and they ask, how would you get a 3D printed house? How much money would it cost?
That's an excellent question. So a 3D printed house is basically done by a really large scaled up 3D printer, like a big robotic arm that would pour out something like concrete, but you could use a range of different materials, I'm assuming. And that would work on a 6-axis robotic arm, so it can move in a range in 6 different directions. And it would just go round and round and round and gradually build that house up layer by layer by layer. How much it would cost? Probably a fair bit at the moment, with that equipment being pretty rare, I think. But once that equipment becomes cheaper to get access to, then I would suggest it would be much, in the long term, down the track, 20 years from now, I think it'll be a much more cost-efficient way for us to build houses, most definitely. But at the moment, pretty dear.
I think, sorry, Mark, I think that house is beautiful that you showed. I think it's a beautiful house.
It is.
I would live in that house. And from the same family in South Hobart, is it possible to print pasta? And what would it be made from?
Yeah, I'm assuming it would be. Basically any liquefied food. So I reckon you could get the raw ingredients for pasta, which would be, you can make some really intricate little ravioli. It'd be pretty awesome.
Yes, it would. Imagine going to a restaurant and they said, "Madam, our pasta has been 3D printed."
Only a matter of time, I think.
We will charge you double. Okay, here is another question from St Joseph's, Queenstown, and it's from Taryn.
Mm-hmm.
How did they print the house? Okay, sorry, we've already answered that one. Sorry, Taryn.
No
From Macy from St Joseph's, Queenstown. How long did it take to build the surfboard, the wake/surfboard?
So I think that was done in about 10 sections, and each of those sections I think would have been probably the best part of 20 hours. So I'm guessing, and now I know my students are going to be watching the recording of this, and they'll correct me on this, but I reckon probably a couple of 100 hours of actual printing, I think.
So quite a long time for something like that.
Quite a long time, absolutely. But look, the thing with 3D printers, you can just run them overnight. You can sit them in the corner of the room. You don't have to keep them
you don't
on.
have to do anything while
Nope.
it's printing away. I mean,
Absolutely.
if we had the video, we could see that the Eiffel Tower is probably
That's right.
finished by now.
That's right, yeah.
Here's a good one. This is again from a homeschool family. Could you print a gingerbread house and furnishings?
What a cool idea. Absolutely, you could. Yeah, gingerbread house I think would be amazing use for that food, Danny. In fact, when I spoke to the operator of that machine at AgFest, that was something she was very keen to explore. So yeah, I think you certainly could, and you could certainly do really cool decoration with it. That's for sure. With it, I know that you can use icing sugar and things like that with it as well.
That'd be good for someone like me who can never make gingerbread houses successfully.
Yeah.
Here's a question from Ada from St Joseph's, Queenstown. How long does it take to build a 3D printer?
Oh, well, I know the answer for a couple of our students who built one year before last was about a term.
Oh, so a long time.
Yeah, so a long time. So there's lots of different, obviously, mechanical components that go into that. And also you've got to understand the electronics and the programming. But it's a fantastic project. But you can certainly do it, but I suppose it depends on your skill levels with all of those different things. But it would give you a great understanding of different bits of technology, that's for sure.
Keep those questions coming in. We've got a couple more here, but it's not too late to post a question. I'm seeing them as they come up as you're posting them in. Here's one from Jack W. from St Joseph's, Queenstown. How long would it take to make a scale of the Eiffel Tower? Well, I guess depending how big it is, but what about that one that you were showing in the video?
Well, for the one in the video, I reckon probably maybe 15 hours. But if Jack wants to build
an actual scale.
Well, look, Jack, I would suggest it would take about as long as it would take me to swim to France to go and see the Eiffel Tower, I reckon.
Can you imagine if you did erect another Eiffel Tower next door to the original Eiffel Tower and it was that bright green plastic Eiffel Tower? I think that would be a tourist attraction too, don't you?
Or gingerbread.
Or gingerbread.
Would be cool.
Just not if it rains.
That's right.
Okay, St Joseph's, Queenstown, you are flying the flag today for questions. Here's one from Nash. How long would it take to build a 3D house?
I would suggest a few weeks, and it would depend on how thick the layers are. One of the things you can do, even with our small scale 3D printers, is determine how thick you want the layers. So the thinner you've got your layer, and you can change all these settings on the software, the longer it takes, but the more detail you get. So with the buildings, I would assume that the layers would be quite thick, but they could probably change that. So it depends on how fine and how intricate your pattern is, and that answer sort of stays the same for anything that you're 3D printing. But quite a few weeks, I would think, Nash. Yeah.
I've got a few questions for you. Well, I've got lots of questions, but one of the questions I had, Mark, was, you mentioned that you can have the plastic filament or you can have concrete or other materials. Do you have to have a different 3D printing machine for the different kinds of material that you're feeding into it?
Yeah, so look, at normal 3D printers, the ones that we use and the ones that you might find in some of the primary schools, there's a small range of different plastics that you can use.
Yeah.
So it depends on your printer.
Filament.
Yeah, so different sorts of filament, and different filament does different things. So one of our students, for instance, worked on a project at last term for Grange Resources. So Grange Resources are a mining company in Tasmania, and they've got a facility at Port Ladder up on the northwest coast, a jetty that goes right out into the ocean. So we needed to build a weather station for the Port Ladder jetty, and what we had to do, because that's in a really horrible place so far as weather goes, we had to make sure that was really weather resistant, salt resistant, wind resistant, sun resistant. So they had to use a very special type of plastic. So there's different plastics for different purposes.
Right.
But if you wanted to build like the house, for instance, something out or food, then yeah, you would absolutely need a different sort
machine.
Of yeah, that's
and
right.
that's a good question that's just come in from Amy. Could you make chocolate pasta?
I reckon you could, Amy, and I'm all in on that. I reckon we should make that a thing.
Mark, just getting back to the filament, can I just lean over and grab that
Certainly.
filament? So I guess just my questions were a little bit about recycling.
Yes.
You mentioned that someone had used some recycled bottle tops when they were making something. Is this filament recycled already?
That particular one isn't, but absolutely there's more and more effort now going into using recycled materials for filament, and bottle tops are a very good and common example of that. So we collect bottle tops from around the university, and we're going to actually build a machine that chops those bottle tops up and then melts them down so we can turn that into filament. So we can use recycled material in a new way to create new products, because I think, one of the things that we have to be mindful of with any sort of manufacturing, any sort of fabrication that we're doing, is the environmental impact. And 3D printers have the capacity that we can use lots of plastic, and that can be detrimental to the environment. But we've also got some really cool opportunities to make sure that we're doing that in an environmentally sustainable way, and we can start to use a lot of the plastic that you'll see around on the planet and turn it into completely new ideas and designs.
Yeah,
so,
absolutely.
Yeah, very important.
I was just thinking if you could do 3D printing, you know, in the future with all recycled materials, that would just be incredible, wouldn't it?
Absolutely, yeah. So that the prosthetic arm that you saw in the slide before, that was done out of fully recycled materials, which is really cool.
What about so say that fantastic what are we calling it? The machine.
The machine.
I'm calling it a tractor,
the
but
tank.
The tank. Sorry, the tank. Can that be recycled? Do you know what I mean? Like, can the components be
absolutely
recycled?
Yeah. So if you can chop and melt things down, you can absolutely do that. Yeah. So you can recycle anything that you 3D print. So any spare filament we can use as well.
Yeah.
So the other thing that we just wanted to touch on really quickly, if we could jump back to those slides for a second, Stuart, is a couple of things that the students might want to have a look at that they can do for free in order to develop their skills. So there's a couple of really good skills that you can develop in order to become a 3D printing expert, and these are things that you can access now. So the first one is the central to all 3D prints is the actual computer-aided design itself. So that's the file, the picture that you create, the 3D picture that you create on a computer that we then send to the 3D printer to print. And the software that we use for that is a thing called Tinkercad, and that's freely available. So that's something that I would certainly recommend. The second thing is not necessarily related to 3D printing, but certainly, you know, as I've shown with the projects that the students work on, a really key component to all of this is those problem-solving skills. And one of the things that you can do for free with stuff that you've got lying around the house or lying around the classroom is to make Rube Goldberg machines. So I'll give you a quick example of both of those. You might have seen a Rube Goldberg machine before, but you might not necessarily know what it's called. So Rube Goldberg machines, basically you just use all sorts of crazy random items to make what is essentially a useless machine.
Oh, yes.
So they're chain reaction machines where one thing leads to another, and you can use, as you can see there's tools from the shed, an umbrella, some ping pong balls, some toys that you might have in the cupboard. You can use toilet rolls, fishing line, basketballs, bits of wood that you might find in the shed. Now this looks like a lot of fun, but there's actually a lot of different skills that you can use that will develop your skills as an engineer by making Rube Goldberg machines. Because you're solving little problems and you're learning to use things in different ways. So it's a really good thing that you can do at home. School holidays coming up might be something fun to try at home. Well, they don't make too much mess. You might drive your parents crazy. But that's a Rube Goldberg machine. And the second one I just wanted to show you quickly, this is Tinkercad. So this is a time-lapse of Tinkercad. So this is a software application that's developed by a company called Autodesk. Now, all of the professional standard computer-aided design that we do at the facility, and certainly a lot of the stuff that gets carried out in industry, uses Autodesk products. And this is a bit of software that they've designed especially for kids. So this is something that can start your journey with 3D design. So you can start really simple, or you can do, I think they're making in this video, in this example, a droid, an R2-D2 model. So that's something that you might want to try over the holidays as well, that you can get on your computer too.
Well, Mark, this has been absolutely fascinating. That's unfortunately all we've got time for today, but I would like to ask you if you will come back and visit us again on UCTV Alive for Kids. And I think you were telling me earlier you might come back and be able to talk about VR.
We could do some stuff on VR and AR.
I'd love you to come back. Will you come back?
I'll be a pleasure.
That's awesome. Thank you so much. Now, just a note, if you've been watching this as a recording from the Children's University, you might like to write a reflection on what you've seen today. And there's been so much amazing things that we've learned today with Mark. Now, you're going to have some school holidays, so we'll all have a little break while you're on holidays, and your teachers have a well-earned break as well. So we're going to see you back on UCTV Alive for Kids on Wednesday, the 28th of July at 9:15, again, as we usually are. And just keep an eye on our Facebook page to find out who our guest is going to be on that day. And don't forget that you can follow UCTV Alive for Kids on Twitter and check out the Facebook page regularly as well. That's all from me. Thanks so much for tuning in, and see you next time.